Today we're going to be working on applications for similar triangles. All right. Now, one of the things that we have to address is how to actually do these problems. So, let's talk about the steps to success. 1. Always draw a picture if one is not given. Just remember, a picture is 1,000 words. Okay? So that's number 1. Number 2. Take the triangles out of the picture. So once you've drawn the scenario, draw the picture of the separate two triangles separate from the picture. It makes your life easier so that you can set up your proportions. 3, you need to highlight the corresponding sides. Solve for the side you're looking for. That's 4. And then finally, use your therefore statements with units. So always, first of all, draw your picture. Second, take the triangles out of the picture and highlight the sides that you're looking for. You need to solve for X or Y or whatever, and therefore state your stuff with your units. So let's see how this plays when we do a real world situation or problem that I give you. First of all, a tree in your backyard casts a shadow 4.5 meters long. At the same time, you, who is 1.5 meters tall, casts a shadow 1.0 meters long. Determine the height of the tree. So let's quickly draw that scenario. Imagine you have a tree like we have right here, and we have our person standing. Now, what we're going to do is we're going to isolate, we're going to create a tree with a triangle. So if you notice, there's my height of my tree, and there's my triangle. There's my height of my person, and there is my triangle. We know that my person is, well, we did say 1.5 meters tall. And we don't know the height of the tree, but we do know the distance of the shadow of the tree, which turns out to be 4.5 meters long. But then me as a person, I cast a shadow 1 meter long. So now what we're going to do is we're going to split off our triangles, and we have triangle 1, which is the big one. And then we have triangle 2, which is the teeny tiny one. So we don't know. We need to determine the height of the tree. So that's going to be this part of our triangle. We have 4.5 here. And we have 1.5 for the height of the person. And it's meters, right? Meters. And 1 meter here. So now what we must do is we must highlight what is common, what is corresponding. So we have this side matches with this side, which means that we have x over 1.5 is going to be equal to, now let's highlight the other matching sides. So now when we match the other corresponding side, we end up with 4.5 over 1. Now, let's cross multiply these two in order to solve for x. So now we're going to get 1x is equal to 4.5 times 1.5, which is equal to, well, 1x is just x, and then we end up with 6.75 meters as our final answer. So now let's go and put our therefore statement. And therefore the height is 6.75 meters. You'll notice that when I was determining the height of the tree, I let x be the portion of the triangle that represented the height of the tree. And that made our calculations easier. Also, when my x value is on the larger triangle, I usually use the large over small ratio that we talked about before. Otherwise, you're going to use, if x was on the smaller triangle, go small over large in order to make your calculations easier. All right, now let's move on to the next problem. And here's the problem. Determine the width of a pond with the given information. So if you look at the pond, we already have our picture, which means we have two triangles. We have a large triangle on the outside, and then a small triangle on the inside here. Now, what we're going to do is we're going to separate those two triangles from the picture. So let's do that right now. Once we've got that, what we need to do is we need to basically just isolate and put all the sides on the triangle. So now the first triangle has 180 here, meters here. We don't know this side of the triangle based on that part right there. And we know that one side of the smaller triangle is 15 meters. And we do know that the other side is 9 meters. So now that we've done that, the first thing we said we had to do is we had to highlight the corresponding sides. Now, the thing that's missing here is the X side here. So this is the side we're going to highlight. So we have X and 9. So remember, because the X is on the larger one, we're always going to go ratio LG over small. So we're going to get X over 9 is equal to, now let's highlight the rest of the stuff that is similar. So now we're going to go and highlight this side here and this side here. Now, once we've highlighted that, we just do our calculations. So we've got big over small is 180 over 15. Now, what we're going to do is we're going to do the cross product to solve for x. So we're going to do this and this. So we're going to get 15x is equal to 180 times 9. And solving for x, and then when we divide by 15 on both sides, we're left with x is equal to 180 times 9 divided by 15. Which gives us x is equal to a final answer of 108 meters. So there is our answer, and then we just state our final answer. Therefore, the width of the pond is 108 meters.